So very good morning to you all, and today we are going to continue with our next point. Okay, so the next point that is related to the numerical part, that is calculation of initial condition when network in steady state. Okay, so up till now we have solved the numericals with zero initial condition, right? And if initial conditions are not zero, then the first we have to calculate the initial conditions. So those initial conditions which are present in the network. So these initial conditions means the values of voltage or current before the operating the switch. So there are the few steps to define or to solve such type of numericals when the network is in steady state. So first steps. Okay, so first step we have, it is draw the equivalent circuit. I'll just write here, draw the equivalent circuit. Okay, before changing the position of switch and obtain initial conditions. Okay, second, draw the equivalent network. Okay, at t is equal to 0, apply KVL or KCL, calculate the required values. And step number 3, that is last one, draw the circuit at t is greater than 0 and calculate the required values. Okay, calculate the required values. So these are what the 3 initial conditions that we are expected to follow. So let us start with the numericals part. So the question we have, in the network, okay, as shown below, all of you note down the same with me. The switch K is opened at t is equal to 0. Solve for V dV by dt, d square v by dt square at t is equal to 0 plus. Okay, t is equal to 0 plus. So the things we have is the node, the switch we have. Okay, then this is what the current source they have mentioned, which is of 10 ampere. The resistor is connected across, the value is 1 kilo ohm, and a capacitor is of 1 fire. Okay. So as per our discussion, we have the stages as. So first step, draw the equivalent circuit before changing the position of switch and obtain the initial conditions. So to draw the same, let us start with step 1. Okay. So the switch is opened at t is equal to 0. That means the switch was initially closed. So at t is greater than 0, okay, the equivalent circuit is, how will be the equivalent circuit at t is equal to 0? It will be a closed switch. I'll just write over here. Okay, it is a closed switch. Okay, so as it is the closed switch, what will happen? Whatever may be the current we had, okay, the same current will be flowing across this circuitry. Is it? So resistor will remain as it is, 1 kilo ohm, and the capacitor, which is of 1 farad. So over at this condition, due to the short circuit branch over here, the same current will be flowing across, okay, and initially current through the capacitor over here, this will be a 0. Therefore, the initial voltage across the capacitor will be, so initial voltage across capacitor, how it will be? It is Vc of 0 minus is equal to what? 0. Now, the voltage across capacitor cannot be changed instantaneously. I'll just write here. Now, voltage across capacitor can't be changed instantaneously. Okay, therefore Vc of 0 plus is equal to Vc of 0 minus is equal to what? 0. So therefore, from this figure or from this circuit, the node voltage V is same as that of the voltage across capacitor. Therefore, V is equal to Vc of 0 plus, which is nothing but a 0. Hope you understood this step 1. Now, the second step. What is the second step? Draw the equivalent network at t is equal to 0, apply KVL or KCL, calculate the required values. So let us start with. So I'll just go with the next slide for this one. Now, the step 2. Okay. So at t is equal to 0, we need to identify. So at t is equal to 0, what is the condition? The switch is opened and the equivalent network at t is equal to 0 plus. This can be drawn like, I'll just draw it over here. It is a open circuit. Okay. Current source will be as it is, 10 ampere. Okay, which is of 10 ampere. V of 0 plus, the value we have already gone through. Current through the resistor, let us define the current through the resistor as IR, okay, which is of 1 kilo ohm, and the capacitor that we have, which is of 1 farad. Okay, and the current through the capacitor, let us define it as IC. Okay, now the network at t is equal to 0, I'll just write at t is equal to 0, switch is open, and at t is equal to 0 plus, network becomes like this one. Okay, so now using KCL at node V, if we apply the KCL at node V, it will be what? 10 is equal to IR plus IC, isn't it? So therefore, if we go with the values of IR and IC, it will be V of 0 plus, that is the potential voltage or the node voltage, divided by R, plus C into d by dt of V of 0 plus. Let us define this one as equation number 1. Therefore, if we want to resolve the, or if we put the values as, it is 10 is equal to V of 0 plus divided by 1000 plus C is 1 farad d by dt of V of 0 plus. But what is the condition? V of 0 plus, we have already defined it as 0. So your equation will be now, how will be your equation? It is therefore 10 is equal to 0, isn't it? So it will be only d by dt of V of 0 plus d by dt of V of 0 plus. It means what? Therefore, d by dt of V of 0 plus is equal to what? 10 volts per second. Okay. Now, what we have to calculate? To calculate d square by dt square V of 0 plus. So what we have to do is, let's differentiate equation 1. We have already defined that equation, right? So the equation will be now equation 1 with respect to what? With respect to time t. Okay, with respect to time, I'll just write here time t. Therefore, d by dt of 10 is equal to d by dt of V of 0 plus, okay, divided by R plus C into dt square, sorry, d by dt square into what? V of 0 plus. Therefore, this differentiation, this value will be 0, 1 by 1000, okay, into d by dt of V of 0 plus, okay, plus 1 into d square dt square V of 0 plus. Let us define those values. All of you have written the same. Should I go for the next slide? Shall we go for the next slide? Please reply. Can you hear me?
Yes, sir.
Okay. Should I go for the next slide, or you're writing down the same? Okay. Vaishnav is saying yes. Okay. So to define the value, that is d square by dt square V of 0 plus, which is equal to minus 1 by 1000 d by dt of V of 0 plus. But what is the thing? D by dt of V of 0 plus is equal to what? We have already defined this value, that is 10. Therefore, d square by dt square V of 0 plus is equal to what? Minus 1 by 1000 into 10. So this value is nothing but what? Minus 0.01 volts per second square. Okay, so this is what the value of v of 0 plus, and this is what the second answer which is being asked by the through the question. Hope you understood. See, whatever may be the steps I have given during the solving or to solve the numerical, blindly you have to follow. At the end, you'll get the answer. Hope you understood. Shall we go for the next point? Shall we go for the next point?
Yes, sir.
Okay, okay.